Alright, so now I'm going to talk about my elbow systems. So for updatable, I have the update that's overridden by the user, but I also have the ability to submit for registration and deregistration, which is the only thing the user has access to. And these in turn, through the scene call scene registration, deregistration. I have a state to assert that I'm doing the correct thing when I'm supposed to, and then a current state, of course. Reference for constant time removal, and then I'll show the CPP. So I create my commands, I register to the scene by calling register this. When I actually want to submit a command for registration, that's submit registration or deregistration, I pass in the appropriate command and then reflect the changes in the current state. Setting the iterator, of course that's the iterator, and then I can return it. For my draw, exact same thing. Pretty much identical, except I can do draw and draw 2D. Submitting for registration works the same way. If I go to my manager for those things, it's more useful if I show the CPP. So when I register, I insert it into my storage list and set the iterator to whatever it was inserted at. Deregistration just erases it by getting the iterator with constant time. So I just erase it from the container. Process elements goes through the entire thing, and anything that's in there, which is anything that was registered, I call update on it, which is overridden by the user. I don't think I need to explain that, as you saw many things updating. But for example, I can move the ship and update, and the changes are reflected by the key presses every frame. Drawable manager, exact same way. Can insert, remove with the iterator, process the elements. I call draw before draw 2D since I want these to process before my sprites. Documentation associated. So for documentation, I have these neat little groups called modules. Anything the user wants to know about update, click update. Relevant functions along with code examples, what they want to do and how they do it. Registration, deregistration. That goes for all of my elbows, alarms, and then I'll come back to this. But yeah, that's how my update and draw systems are working. My alarm system, way bigger. So for alarmable, I have 3 alarms set up, so what I can do is submit for registration, deregistration, get the time, which is the time it was put in with, get the remaining time, which is the time left, and set the time, which is really just adding time to the current time. These are overridden by the user, so 0, 1, 2. Trigger alarm is what's called by my alarm manager when it's processed, when the elements are processed, and it passes in the ID to know which one to trigger with the switch statement. Remaining time, I need to have remaining time on it. Adding time is what, actually, so set time is different from adding time. With add time, I get the current time and then add on to it. I'll show that right now. This is closed off for the user. I can set the iterator and get it. I have registration state. So registration data, since I wanted multiple alarms, this is the only way to do it, but there's a struct for registration data. Each one has its own reference, state, registration, deregistration command, ID, time, and remaining time. I have 3 alarms, so that's an array of 3. So alarmable. Again, set up the same way with all the assertions. I can submit registration and deregister, but this time I have to update the variables, so the time, remaining time, and the current state is all updated based on the alarm ID. Trigger alarm again is a switch statement, and then if I want repeating alarms, I have to deregister as soon as it's triggered. Otherwise, I couldn't have repeating alarms. This add time is deprecated. I'll show what it actually is in the alarmable manager. Oh, this alarm enum is what I use for the alarm ID instead of integers, just safer. And then if I go to alarmable manager, so when I register, I create this thing called an alarm event, which is the pairing of the ID and the alarmable pointer. And then I insert that into a timeline map, which is just a map of the time. So when I want to insert it, I want to insert in real time. So that's the current time plus the time given by the user. So when that time is reached, it'll trigger. The second one is the alarm event pairing of the ID and the alarmable. I insert it, get the iterator for constant time removal. And then I can deregister that here with the erase and then getting the iterator. So adding time, I go through the whole thing. I match the alarmable and the ID to make sure I'm at the right one. And then I call add time on the alarmable with the remaining time plus the new time that the user wants to add, of course. Then I increase the iterator. Get remaining time, it again matches the alarmable and the ID to make sure I'm at the right position. And then I return IT first, which is the float time that I inserted it with, minus the current time in seconds. Otherwise, if it doesn't exist, return 0 because the alarm wasn't set yet. Process elements, go through the entire thing and then call trigger alarm on the appropriate alarm ID. And then erase it from the map. So the timing shown at the bottom here. So it spawns when it reaches 0, 6, 5, 4, 3, 2, 1. Another ship will spawn. There you go. And the adding time, it was actually already shown. So I was adding 5 seconds there, but can remove that. So after I register for the alarm, I add 5 seconds. This is respawning. You saw when it counted down 6, 5, 4. If I remove that, now they'll spawn every 2 seconds. So I stopped adding time, so there you go, 2, 0, and they spawn much faster. Close that out here. I was on my alarmable manager, I believe. Yeah, that's the alarm system. I can show the documentation. Oh, yeah, pretty much everything I had already shown. For my keyboard input system, exact same way, so I can submit for registration, deregistration. I have an enum for an event type, where I either have a key press or key release. When I register things as key objects. These are the functions that are written by the user, so what happens when it's pressed or released. These key objects that I'm talking about. So when I register with an inputable and a type, and I set the key of that key object through here. Destructor just clears those lists. But when I register, I push back with that inputable based on the type, so it's either key press or key release. When I deregister, I deregister for key press or key release. Again, that needs to be specified by the user. So checking status, this is called every frame. So I check to see what the current state of the keyboard is. If it's now pressed down but previously it wasn't, that's a key press. So I go through my key press list and call a key press on anything that was registered. Otherwise, if it was previously down, but now it's up, which means it was released, then I go through my key releases and then call on key release, which is overridden by the user. And then of course my previous state is now my current state, so I reflect that change. If I show, like, say, my frigate, which is now my tank, on key press, so you saw when I press T, I create a bullet, it says T key pressed. Releasing R, set to the next scene. I believe I have this to showcase turning off my registration. Whoops, key event registration. So alarm 1 will deregister my input for T, so I can no longer shoot bullets. There you go. So now I'll spam bullets, but eventually I won't be able to because after a certain time it gets deregistered. There you go. So either I'm pressing T, I mean nothing happens because it was deregistered. So there you go. Keyboard input, anything else? Associate documentation, which is under input, hopefully, with example code and things that the user needs to know. Next is my collision system. So I'll start with my collidable base class. So I have a default collision along with a collidable. Since this is templatized, I need to submit registration with the object. So I submit the command templatized. My collidables have a B-sphere, which I'll get back to. I can set the collider model based on whatever the user passes in. Updating the world's data of that model to follow the graphics object. And then registration is closed off to the user. They need to submit first. So for actually registering, that happens in the groups. So if I can find collision, I believe it's under managers collidable group. Okay, so what a group is, it's a templatized singleton. So when I register to a group, I create a group of whatever object that is. Then I add it to my collidable collection. So I either insert it or erase it based on register or deregister. I believe this is empty. So it derives from a group base, so I can have an entire collection of them. My collision manager has the process collision test, so that's called every frame, of course, after update. These commands are what I was talking about, so I'll go through them right now, but they're commands to test either self or with a pair, and a collection of those groups that are the singletons of the templatized type. When I call set collision pair at the scene level, I insert the pairing of the two types that I want. With self, I just insert that single instance of itself. And then to showcase those commands, they're here. So I actually didn't show, I just realized my other commands, but they're all set up pretty much the exact same way. So for registration commands, they just call the scene level registration. But my collision's a bit different, of course, for the test commands at least. So for test self, upon execution, I have two iterators in the same list. So I start at the beginning, and then the second iterator is the one next to it, so that it never overlaps. But I compare the intersection. So if that intersection is true, then I call collision on both respective objects. So with pair, it's the exact same thing, except I have two collections, of course, for the different objects. So they're starting at their own respective sets or collections. And then if the intersection is true, then I just call collision on those objects. Yeah, and then of course those are only run once. They're not run like multiple times, so they're not overlapping. As you saw, things only get destroyed once, and the output only says it once. I was going to show, right, collision volume B sphere. So these are the things that are actually causing the collision. So when I compute data, that's the data that's updated. So I recompute the radius in the center based on the matrix that's passed in and the model. So that's the info that's recomputed every frame because it needs to reflect the changes of the actual graphics object. Intersection just calls my math tools intersect with the B sphere and another B sphere. And then show that here. So this is my math for B sphere intersection. So I compute the distance between the two centers, the length of it, and then I get the sum of the radii. And if the distance of the centers is less than or equal to the sum of the radii, I return true, meaning there's an intersection, otherwise false. And again, that's the test I do for collision, which is again showcased in my commands here. How that's reflected. So on my main page, I show the user how to set up the collision pairs and collision self. Collision stuff is under this group here with example code for how to set the collider model, what it needs, how to deregister and register, and what update collision data is for. So you saw my B spheres following my tank. So you can see that these are updated appropriately following my models, and also the collision is spot on. If I go to my tank, so I set the collider model in the constructor, which is a just a B sphere. So it's under set collider model. When I submit for registration and collision, I pass in the type and this. When I want to update those changes, since I want the B sphere to follow, I do update collision data and pass in the new world, which is just all the calculations done after. And so it follows the graphics object. And then upon collision, colliding with enemy, you saw that the hearts deplete, and then at 0 I restart the scene. And then I have colliding with enemy or colliding with enemy bullet. So that's how collision was working. Game object lifecycle, I'm showcasing that with the bullets. So user base classes, game object. I can submit for entry and submit for exit. I have the same assertion and registration stuff here, like all my other ubbles. But since it's for a life cycle, I can showcase that in my bullets. So I have a bullet factory, and it has a collection of recycled and active items. When I create one, I instantiate a new one, pass it in through active items. Otherwise, if it already exists, I get it from recycled items. And then I can call initialize, and then I submit it for entry. And then, if I actually showcase what that is, when I submit for entry, it goes through the registration process, but finally I can do scene entry. As you can see, I don't submit for update, draw, any of that in my constructor. So clearly it's not happening when it's created, but only when scene entry is being called, so that is indeed working. Scene exit, you saw the bullets died when they hit something or when they timed out. So I deregister for all this stuff. And then of course I recycle the bullet back. Yeah, and then since it's life cycle, I need to showcase my factory working properly. So I shoot 3, so it should be recycled. I'll close this down. You'll see recycle stack size 210, so 3 were indeed deleted. And then for active items, 1, 2, 3, so those are active. I closed down really quickly. And now instead of recycled, it should say active stack. And then you can see here, there's no recycled stack since those were active. And then there were 3 active objects. So what I do for that is just at the end, since they were updated appropriately based on whether they're active or recycled, I just go through the entire stack and delete them. And then, yeah, it's pretty much how that life cycle is working. I only have it for dynamic objects, so that's my bullets, my enemy bullets, and the actual enemies. And those all have the same factory setup. The documentation for this. Game object. Excuse me. Anything relating to game object is just set up under here. And do game object. Here's the actual class, sorry. Descriptions and examples. And then I'll cut it off here. In the next video, I'll talk about sprites, the visualizer, and some of the other engine stuff. So, 1 second.